Hello, welcome to my channel. We will be solving these past exams. Right now, I have this May-June 2025, Volume 41, and it is Mathematics and Mechanics. So let us start the problem. Uh, it has 7 questions as usual. So the first question is, okay, yes. So a block of metal 12 kilogram is being pulled by a rope up a rough plane. The plane is inclined at an angle of 20 degrees above the horizontal. The rope pulling the block is parallel to the line of greatest slope of the plane. The coefficient of friction between the block and the plane. This acceleration of the block is this. Okay. So this is the scenario. We have a inclined surface which is making an angle of 20 degree with the horizon, and on the surface there's a block, and the mass of the block is 12 kg, and it is being pulled by some force of tension T. Now the block is being drawn downward because of the slope, and that downward force is mg sine theta, right? At the same time, there is a frictional force which is opposing this movement, and that frictional force is mu mg cos theta. Okay, so the net force working on this block is tension minus mg sine theta minus mu mg cos theta. And this net force is equal to mass times acceleration of this block. And this block is being accelerated up by an amount of 2 meter per second square. You see, this is it. This is it. Okay. So from this expression, we can isolate the T. So the T is equal to, if I take everything on the right side and take M as common outside, so I have A plus G sine theta and plus mu g cos theta. So M is 12 kilogram, A is 2 meter per second, plus I will take G as common outside, and G is 10. So inside is sine of 20 plus mu is 0.4, 0.4, and cos of 20 degree. Okay. So when I calculate all these things, it comes out to be 110.15 Newton. Okay, easy. So this was question number 1. I think it's pretty straightforward. Now question number 2. Okay. Uh, Three coplanar forces of magnitude P Newton, this is P Newton, working vertically upward, and 10 Newton and 5 Newton. So this is 10 Newton, this is 5 Newton, and acting at point O, as shown in the diagram. The resultant of the three forces has magnitude Q newtons and acts in a direction perpendicular to the force of P Newton. So this resultant force is somewhere along x-axis, this direction or this direction. Find the value of P and the value of Q. Okay, so we need to find the value of P and the value of Q. Okay, so sum of all forces along x-axis has a resultant force of Q, right? Okay, so what is the x component of this 5 Newton force? Of course, this is 5, and into cos of 60 degree, right? This is the x component or horizontal component of this 5 Newton force. And negative, because this 10 Newton force has an x component which is in the negative direction. So negative 10 into cosine of 30 degree. Okay. And this is equal to the force Q. Okay. So from here, We find that q equal to 5 and to cosine of 60 degree is half, so 0 0.5 minus 10 and cosine of 30 degree is square root of 3 by 2 or 0 0.866. Okay. And we found this thing as negative 6.16 Newton. It means that this force is working in the negative direction. So this is the direction of our Q force and the magnitude is 6.16 Newton. Okay, now let's talk about the vertical forces. So the vertically upward force is P Newton plus 5 and sine of 60 degree. These two forces are working vertically upward minus the vertically downward force is 10 into sine of 30 degree. Okay. And this resultant is zero because we are told that the resultant of all these three forces has only exist only in the horizontal direction. There is no vertical component of these three forces. So the sum of these three forces has to be zero. So from here we can calculate, just find that the P is equal to 10 sine of 30 degree and minus 5 of sine 5 into sine of 60 degree. Okay. So P is 10 sine 30 minus 5. And this comes out to be, the sine of 30 degrees 0.5 and this is 0.866. So this, let me write it down, right? So 10 into sine of 30 degree is 0.5 minus 5 into sine of 60 degree is 0.866. And this all comes out to be 0.67 Newton. Okay, so these two questions are easy and straightforward. Let's do the third question now. Okay. Uh, the diagram shows the velocity time graph of a motion of a cyclist. The graph consists of three straight line segments. The cyclist passes a point O with speed 3 meters per second. So when they start the observation, his speed was 3 meters per second. At time 0, the speed was 3 meters per second. And then accelerates for 10 seconds with constant acceleration of 0.5 meter per second. So in this interval, when in the 0 to 10 second, his acceleration is 0.5 meter per second squared. Okay. He then traveled at constant speed for 30 seconds. So this is 30-second interval where his speed was constant. Okay, how much was that speed? So in this interval, we know that it was accelerating. So the final speed Vf is going to be Vi plus At. So initial speed Vi is 3, acceleration is 0.5 meter per second, and time is 10 seconds. So 10 times 0.5 is 5, 5 plus is 8. So this is 8 meter per second. So this speed is 8. Okay, so with 8 meter per second, it goes continue for 30 seconds, right? Okay. Uh, Constant speed, okay. No, sorry. The graph consists of three, yeah, the cyclist passes through point, okay, yes, and then accelerate for 10 seconds with constant speed, okay, yes. He then travel at constant speed for 30 seconds before deaccelerating. So this is the point when he's deaccelerating, his speed is becoming smaller now. Coming to rest at P, covering a distance of 80 meters while deaccelerating. So while he's deaccelerating, the total distance he covered was 80 meters. So the area of this curve, this area, this must be 80 meters. And I do not know the end time. Let me call it T. Okay. Find the total time taken for the journey from O to P. Okay. So the total time just taken is 0 to 10, 10 to 40, 40 to T. So we need to find the value of t here, right? Okay. So we use this information which is given at the end, that while he was deaccelerating, he covered a distance of 80 meters. So this area, the area of this triangle must be 80. Okay. So 80 is equal to, the area is half, and the base is t minus 40, and the height is 8. Is it clear? So in this expression, we have to isolate, find the value of t. Okay, so this is going to be 4, right? 2 for the 8. So I will divide it, the 80 by 4. So 80 by 4 is equal to t minus 40. So 80 by 4 is 20. So t is equal to 20 plus 40. So this is 60 seconds. Okay. So the the total time from here to here is 60 seconds. Okay. So this was easy, very easy. Now let's do part B of this thing. Uh, this is part A, and yes, part B. Okay. So on this given axis, sketch a displacement time graph for the cyclist journey from point 0 to P, showing on your graph the distances traveled after 10 seconds and 40 seconds. Okay, so you see, after 10 seconds, right? So displacement at 10 seconds, okay? That is equal to the area under this trapezoid, okay? And that would be 3 plus 8 divided by 2 and times the base, which is 10. Okay, so how much is this? I calculated it here. So this is going to be 55. Makes sense? Okay, now the this distance traveled at 40 seconds. That is this area plus this area. So I have to add these two areas. So the first area is 55 plus the area of this rectangle is 30 times 8. So 55 plus 20 to 40. So this is equal to 55 multiplication. So it is 240 plus 55, the 295. Sorry. And the distance traveled at 60, which is t, is this distance, which is 295 plus 80, right? The distance traveled while he will be accelerating. So plus 80 gives us 375. Okay. So we know all these three distances. And now let's try to sketch the displacement time graph, right? Okay. So in the first 10 seconds, it was accelerating. So as time goes by, the distance level is increasing. So the graph will be something of this shape. Okay. And we know that at this point, the distance level was 55. Okay. Uh, okay. So now from 10 to 40, for this 30-second interval, his speed was constant, right? So if the speed was constant, then it will keep traveling the distance at the same rate. So it will be straight line from here to here. Okay, so this is the point where we have time 40 seconds, and the distance covered up till this point, as we have shown before, it is 295 meters. Okay, so here we have a type of curve here. Okay, and here it is a straight line. Okay, from 40 to 60, right? To 60, I just want to make sure. Yeah, 60. It is 375. Also, now, in this last 20 seconds, it was deaccelerating. So the rate of increase of the distance is slowly decreasing. Okay. So when it reach at 60-second mark, the distance traveled is only 375, I believe. Yeah, yes, it was 75. Okay. So you can see that in from this point to this point is the straight line. Before this, it was a curve, right? Concave or concave up, and but here it is again a curve, it is concave down. Okay, so I hope this question is also clear. Now we have question number 4. Let's do it in the next video. Thank you very much for watching. I hope you enjoyed it. See you in the next video.